Sample problem 3.12 deals with balancing chemical equations. And so in order to do this, we have to follow a certain set of rules. And if you'll notice, I have the steps listed over here on the left side of the problem here. And we're going to use those in order to solve this problem. So let's get right into it. The problem says, within the cylinders of a car, the car's engine, the hydrocarbon octane, C8H18, one of many components of gasoline, mixes with oxygen from the air and burns to form carbon dioxide and water vapor. Write a balanced equation for this reaction. So the first step you see listed there is to translate the statement. All right, so that's what we're going to do first. So I'm going to use the wording of the problem to clue me in on what are my products and what are my reactants? Because that's the first step, right? We have to identify what those things are in order to write a balanced equation. So let's see. It says hydrocarbon octane mixes with oxygen from the air and burns to form. So those two things listed there, those are going to be my reactants. So I'm going to write those first. And they gave me the formula for octane, H18. Now we also have to include the physical states, okay? Which actually, let's just wait till the end. That's actually listed as the last step, so we'll talk about that towards the end. So let's just do this first. So plus oxygen from the air, right? That's O2. That's the oxygen that we breathe. Yields, because it's the next thing there says that they form. So anything that's being formed, that's going to be a product. That's going to go on the right side of my yield arrow. Carbon dioxide, so I have to convert that word into the molecular formula, CO2, using the rules from Chapter 2 again, remember, plus water vapor. And the formula for water is H2O. So now I've done my first step. I've translated the statement. Now I have to balance the atoms. So I'm going to start with carbons and hydrogen. I'm going to tell you why. Anytime you have an element or an atom by itself, save that one for last because it makes things easier, I can promise you. So I have 8 carbons on the left side of my yield arrow and only 1 carbon on the right side. So if I rewrite it down here, H18 plus O2 yields, I'm going to put 8 CO2s plus, and I'm going to see about my, I'll go ahead and write this, and I'll leave enough room so I can write a stoichiometric coefficient there. That number that I just wrote, that's the stoichiometric coefficient. And notice that I did not just change and put a subscript here and call this C8O2. If you do that, you have changed the identity. This is no longer carbon dioxide. So you can't just add subscripts to fix the balancing. You have to add these stoichiometric coefficients, which go out front of the formula listed for that particular molecule or element. So I've got 8 of those. So now I'm going to look at my hydrogens, and let's see, how many do we have over here? I only have 2 on the right side of my arrow, and I have 18 over here on the left. So what times 2 gives me 18? That's 9, right? So I'm going to put a 9 in front of my H2O. Now I've saved my oxygens for last, so let's see what we have here. I've got 2 oxygens on the left. I've got 8 times 2 oxygens over here on the right, so that's going to be 16 oxygens, plus I've got 9 oxygens from the water, so plus 9 equals 25. So I've got 25 total oxygens over here on the right, and I've only got 2 over here on the left, so I've got to ask myself, how can I turn 2 into 25? You know, what can I multiply by 2 to get 25? And the answer to that is 25 halves. Right? Because 25 halves times 2 is 25. Now, the next step says we have to adjust the coefficients. And what that means is, in other words, we can't leave this as a fraction here. So I can't leave this number as 25 halves. These stoichiometric coefficients have to be whole numbers. So what do I do to turn 25 halves into a whole number? I have to multiply it by 2. And if I multiply that one by 2, I have to multiply the entire thing by 2. So I'm going to put brackets around that, and I'm going to put a 2 outside of there, meaning I've got to multiply everything in those brackets by the number 2. So I'm going to rewrite the equation here. I've got 2 octanes now, because I started out with 1, right? And 2 times 1 is 2. plus 25 oxygens, because 25 halves times 2 is just 25, yields 16 carbon dioxide, CO2s, because 2 times 8 is 16, plus 18 waters, H2O. Let me zoom out a little bit so that looks a little better there, my oxygen. There we go. 18 H2Os. Now that we've done this and changed things a bit, we have to check that the atoms balance. So let's see, I've got 2 times 8, so that's 16 carbons on the left of my arrow, and I've got 16 carbons on the right of my arrow. I've got 2 times 18 hydrogens on the left, which is 36, and I've got 2 times 18 hydrogens on the right, which is 36 hydrogens. I've got 25 times 2, which is 50 oxygens on the left. I've got 16 times 2, which is 32 oxygens, plus 18 oxygens, so that, which equals 50 oxygens on the right of my arrow. So now I've checked, and I've got the same number of all of those atoms on both sides of my yield arrow. And now I just have to do the last step. I have to specify the states of matter. So I'm going to rewrite it one more time. 2C8H18. And you've all gotten gas before at the pump, right? That's a liquid. Plus 25. This is oxygen from the air, so that's a gas, right? We breathe that in. Yields 16 carbon dioxides. That's exhaust that comes out of your tailpipe of your car, and you all know that's a gas, right? Plus, they said water vapor, so I'm going to have to come down here because I'm out of room. 18 H2Os, and a vapor means that it's in the gaseous phase, right? So there we've had it. We followed all of our rules, and we now have a balanced chemical equation from this statement that they've just given us here.